This is part 2, worksheet 6A, and given the loading condition, design the smallest possible diameter for the shaft. Use a factor of safety of 1.8 with respect to yielding. So that is the design problem. So part number 2. So let's go here. Part 2. So basically, design the minimum diameter. Design for the minimum diameter. The part number 1, they give us the diameter is 4 inches. And now they want whether we can go with smaller one. So when it about design, you remember the general design equation: allowable level and actual level less than allowable level. You recall that, so you have it actual less than allowable. And what are the level we are talking about here? Because that is the torsion, and torsion create the shear stress. So in this case, we have to mean tau shear stress actual. It has to be less than tau allowable. And for the actual, if you recall the equation for the actual, for tau, here T rho over J, and its maximum, we have to decide the actual maximum when rho equal to C. So what does that mean? We will have T C over J have to be less than the failure mode. For this case is the yielding shear stress Ty divided by the factor of safety to get the allowable shear stress factor of safety. And from that we can plug in with the equation here. We will have, so T, of course we design for the maximum. The most critical components segment in this shaft is CB, because they get the maximum torsion 6 foot kips. So if we design for that CB, then every other segment should be okay. So from that we can start with the maximum here, which is 6 times 12. Why 12? That is to change that to from foot kips to inch kips per foot. And then C, this is the question one to find out. So C unknown in this case. The previous one, C is 2 inches, given the radius is 4 inches. But here they want to find out, so we have that. And J is 5 over 2 C4, and less than or equal to Ty. For this problem, they give us is Ty 51 KSI, so we can plug down here. KSI 51 divided by factor of safety, they gave us 1.8. From that we can have C greater than or equal to 1.174 inch, and they ask us for diameter, so you just time by 2, so you get the diameter is equal to 2.35 inches. So what does that mean? The given in the part 1 is 4 inches is more than enough. We only need at least 2.35 inches. With that, we're done for the part 2 of worksheet number 6A.